Okay, so last 2 minutes, na? Try to conclude. Projector. Okay, all right. Now stop. 10 minutes only every day. So, audible hai? Okay. So in UPSC, they are not interested to know whether you know the definition of heat budget or not. So this is a class 12 like a content. So if you are writing a simply a definition, तब तो you'll get in a very ordinary marks. Like not even average marks, close below average. So read your definition.
Heat budget is a quantitative analysis of heat which balance and impact solar radiation with outputs.
You try at least. Like it is a quantitative or qualitative, quantitative distribution of incoming and outgoing, है ना? Here you have tried to put in a 1 point. ठीक है?
Receives heat energy from resources, insulation, radiation, and hydrogen process, out of which insulation is most significant. Then the other two, it is a form of shortwave radiation consisting of the whole electromagnetic spectrum. The amount of incoming shortwave solar insulation retains an equilibrium with the outgoing longwave terrestrial radiation. This is what it is.
Heat budget. So actually we are not required to explain in this way. We need to explain, but we need to explain in an analytical way. So what you have written, it needed to be captured in a one line only. So heat budget is an indicator of heat balance, which makes an equilibrium between inflow and outflow. बस अब क्या करना है ना, what do you need to do? तो सबसे पहले तो this is a 150 words question. This is a 150 word question, ना? जो भी question था, it is 150 words. So, and then we have to describe its component also. So first we'll see how to explain, ना? तो मैं यहाँ पे लिख रहा हूँ heat budget. देखना अप्रोच बदल जाएगा आपका. So every day 10-20 minutes we're going to analyze the topic we have studied yesterday. So if we have a heat budget here, so इसके थोड़ा सा यूटिलिटी देखते हैं. फर्स्ट वी गोइंग टू सी द यूटिलिटी. ठीक है? सो हीट बजट इज अ फिनोमेना ऑफ लिथोस्फीयर, एटमॉस्फेयर और हाइड्रोस्फीयर. हीट बजट टेम्परेचर है ना, बैलेंस टेम्परेचर ऑफ एटमॉस्फेयर ओनली. इट इज इंड्यूस्ड बाय लैंड एंड वाटर बोथ. ठीक है? तो इट इज एटमॉस्फेरिक फिनोमेना. एटमॉस्फेरिक. ठीक है, पहले तो हम ये देख रहे हैं फिनोमेना. ओके, दो इट इज इंड्यूस्ड बाय लैंड, वाटर, है ना, एंड लाइक लैंड में भी फीचर्स एंड ऑल. अब ऐसे करके सोचो जरा, व्हाट आर दी अदर फीचर्स यू सी. डू इट इन अ रफ उसमें, व्हाट इज द नेम, like other factors we have. अच्छा, it is in a what? Daily phenomena or annual phenomena? So it is an annual phenomena. Annual phenomena. Annual phenomena. Okay. Now it means we have a regional variability, है ना? And it has a regional variability, regional as well as seasonal variability. So we have a regional, seasonal variability. अच्छा, अभी हम सोच रहे हैं ना, वी आर मेकिंग एन अ पॉइंट. आप भी ऐसे रखो बीच में, मेक इन अ नोट्स हिट बजट हियर एंड डेवलप ओपिनियन, तभी ओपिनियन आएगा ना. डू इट विथ मी, डोंट डू दैट देयर ना. लेट अस वर्क ऑन अ फ्रेश पेज. एक फ्रेश पेज में बीच में लिखो आप, है ना, बीच में. राइट, इफ यू होल्ड इन अ पेज है ऐसा, इफ यू होल्ड इन अ पेज तो बीच में लिखो हिट बजट and then start developing a point इस पे. Okay, now it is an okay definition तो हमने देख लिया ना. पहले तो definition we have seen, जो आपने definition लिखा है. It is a balance between incoming outgoing. That is the bookish answer. Outgoing. अब और सोचते हैं हम ना, we need to explain, and we have to explain in a network basis में, like comprehensive way. If you are explaining in a bookish way, you will have no value. Like UPSC will think that you are the bookish one, you cannot make policy. तो हमें लिंकिंग करने का आदत होना चाहिए, नेटवर्क बनाने में उसको. ओके, तो डेफिनेशन डन ना. रीजनल वेरिएबिलिटी, व्हाट इज, which force is a guiding force, like out of the transfer of an energy, which is dominate, like a most dominating pattern of movement of heat energy, due to which it is guided. Convection, radiation or conduction? Radiation, है ना. It is actually driven by radiation. Driven by radiation. Radiation. And which radiation? Both radiation, है ना. So driven by both solar radiation as well as terrestrial radiation, है ना. Is it driven by both? ऐसे लिखते चलो आप भी फ्रेश पेज में ना. And I am giving you a chance so that you can write your own answer. आगे सोचो अपने ना. मैं आपको बता रहा हूं कि अपने दिमाग को जिंदा करना है हमें. We need to make an analysis in a manner so that we can write our answer, ना, not bookish answer. Your answer. तो इसमें बताना है कि अभी तो आई एम गिविंग अ पॉइंट ऑफ व्यू यहां पर. टेल मी मोर पॉइंट, जो आपको कैसा लगता है. इट इज अ व्हाट टाइप ऑफ फिनोमेना एटमॉस्फेयर का. इट्स ऑर्डिनरी फिनोमेना और इंपॉर्टेंट फिनोमेना. इंपॉर्टेंट को भी और क्या वर्ड लगा सकते हैं, उसके भी ऊपर और सोचो सर. हाँ, क्रूशियल, वाइटल, है ना, विच डिफाइंस व्हाट, लिविंग कंडीशन फॉर द ह्यूमन बीइंग, लिविंग बीइंग. इसको भी लिखो, इट इज अ वाइटल. इट इज अ वाइटल, है ना, फिनोमेना, बिकॉज इट क्रिएट्स अ गोल्डीलॉक टेम्परेचर. गोल्डीलॉक टेम्परेचर, ठीक है. गोल्डीलॉक टेम्परेचर, यू नो, इट इज अ टेम्परेचर विच इज सुटेबल फॉर ह्यूमन बीइंग, है ना. और सोचो जरा, और क्या हो सकता है. इट इज अ हीट बैलेंस, यहां तो हमने सोच ही लिया है ना. इट इज एनर्जी बैलेंस. हीट बैलेंस इज एनर्जी बैलेंस. एनर्जी बैलेंस. अभी मैं आगे सोचना सिखाऊंगा आपको. एंड हीट उसके बारे में. अच्छा, इट इज सपोर्टेड बाय ओनली लैंड और डाइवर्स इकोसिस्टम. तो इसको भी लिखो यहां पे. इट इज सपोर्टेड एंड कॉम्प्लीमेंटेड बाय डाइवर्स इकोसिस्टम इकोसिस्टम, रेगुलेटेड बाय लैंडस्केप, है ना, रेगुलेटेड बाय लैंडस्केप। समझ में आया इसमें? अच्छा, अब इसमें कौन कौन से लाइक इसके कंपोनेंट तो इस डिफरेंट पॉइंट है। ओके, चलो इतने ही में हम करते हैं, आज ज्यादा नहीं करेंगे बिकॉज एवरीडे विल गोइंग टू टेक लिटिल एफर्ट्स ओनली। ठीक है, अब ट्राई करो जरा। अच्छा, बिटवीन दिस ड्राइविंग फोर्स रेडिएशन एंड टेरेस्ट्रियल रेडिएशन, विच इज एन डोमिनेटिंग वन? सोलर रेडिएशन। सो इट इज रेगुलेटेड बाय सोलर रेडिएशन, है ना, एंड लाइक रिस्पॉन्डेड बाय टेरेस्ट्रियल रेडिएशन, ऐसे बताना है। रेगुलेटेड बाय, नॉट रेगुलेटेड, उसको डिक्टेटेड बाय सोलर रेडिएशन एंड रिस्पॉन्डेड बाय टेरेस्ट्रियल रेडिएशन। अब चलो इस पे एक पैराग्राफ लिखो आप, इसमें से क्लब करके। ट्राई टू टेक 2-3 पॉइंट, जैसे इट इज एनुअल, वाइटल एंड यूनिक फिनोमेना ऑफ एटमोस्फेयर वेयर, ऐसे करके ट्राई करो, 2 सेंटेंस ओनली। I'm giving you a clue so that you can start thinking differently with your competitors. अभी तो इसमें वी हैव 1 more राउंड ना, अभी तो मैं ज्यादा नहीं करा रहा, आई एम जस्ट गिविंग यू 1 point so that you can write some your own analytical answer. नहीं तो यूपीएससी में क्वेश्चंस आर इजी। And that is why right from the beginning I have emphasized you all to think and write. So पहले लिखो रफ पैराग्राफ, देन मेक इन अ सेकंड राउंड और रिफॉर्म पैराग्राफ, फाइनल पैराग्राफ, ऐसे लिखते हैं। डोंट ट्राई टू मेक पॉइंट इन अ फर्स्ट गो। रफ पैराग्राफ, रिफॉर्म पैराग्राफ, है ना, रिफाइंड पैराग्राफ एंड देन फाइनल पैराग्राफ। तो पहले तो एक पॉइंट लिखते हैं हम लोग, इट इज अ यूनिक, वाइटल एंड एनुअल फिनोमेना वेयर इनकमिंग इज rightly balanced by outgoing, which decides the energy balance of the earth system. ऐसे करके लिखो कुछ, don't take my words. Okay, try. क्या लिखा? हाँ, good, है ना? Now it is bit different from the your first attempt, है ना? आपने क्या लिखा? हाँ, तो ये जो लास्ट वाला लिखा ना, इट इज अ वाइटल फिनोमेना, इसको पहले लिखो आप पहले। इट इज अ वाइटल यूनिक, एक बार ट्राई करो, देखना आपका चेंज हो जाएगा थॉट. इट इज अ वाइटल, ऐसे ही उसी में लिखो आप ऐसे करके, या पढ़ लो उसी को पहले. इट इज अ वाइटल यूनिक एंड डिसाइसिव फिनोमेना एज इट क्रिएट्स एन गोल्डीलॉक टेम्परेचर. और फिर उसके बाद वो पढ़ो आप, एक बार फिर से करो. हाँ वेट वेट, मैं यहाँ पे ये बस आप सबको बताना चाह रहा हूँ कि डोंट टेल वन वर्ड, because if you are writing in a paragraph, we have a scope to adjust many ideas. So it is a vital, and try to accommodate these words also. It is a vital, annual, unique, ठीक है, atmospheric phenomena. यहाँ भी लिख देना आपको, ठीक है. It's a white. So in that way, in one line, we are incorporating many words. ठीक है. अब ट्राई करो, आप धीरे से पढ़ो. It is a vital, unique.
It is a vital, unique, and good phenomena for maintaining the Goldilocks temperature of Earth. Where equilibrium between incoming and outgoing energy is maintained. It is dependent on seasonal variability and driven by solar and terrestrial radiation.
Yes. वो थोड़ा improve ना? उससे पहले वाला like it was a bookish answer where you are writing. Now this is you are doing what? Writing your analytical answer. अभी analysis नहीं आया. I'll guide you later on. अभी धीरे धीरे करेंगे हम ना. Okay, so this is the first point. Now what is the second point you need to do? Is that question का second part क्या था? Describes its various component. So heat balance में, in heat balance we have a two parts, incoming and outgoing. So you have to list all phenomena of an incoming. We have albedo, reflection, we have a scattering, then we have absorption, effective radiation, diffusion. You have to club all these one side. Then here you have to tell like convection, radiation, conduction, and then re-radiation from atmosphere. You have to club these all phenomena this side. So you have to club all these phenomena in a short paragraph or point, and then you have to tell कि देखो जो paragraph क्या करता है, this albedo and reflectivity like mitigate or like it retard the intensity, incoming intensity, whereas diffusion and absorption defines the effective radiation of the, like you have to tell अपना point of view बताना है, सब में अपना point of view. If you are not telling your point of view, you are not demand like settling in a question according to a UPSC's demand. ठीक है, तो take it as an assignment, full assignment. What you need to do, you have to write heat balance, उसमें explain करना पहला कि why it is important, starting जो हमने किया. Then you have to give in a 1-2 line bookish जो sentence है. Then you have to tell it has an incoming variation inputs which has in a following components. ठीक है, and what is their subjected roles, and then outgoing, that is what is your role, and then conclusion. Later on I am going to explain conclusion इसके बाद. Okay, ठीक है. So now we will going to see the content we have discussing yesterday. Every day we will keep in a 20 minutes, 20-30 minutes. It is very vital because if you are not giving in a this exercise daily, इसका मतलब है कि simply you are coming here to make notes. Notes तो ऐसे ही मिल जाएंगे. In market we have every notes are available. Learning will come when you will indulge into this exercise. ठीक है? Okay. चलो फिर we were discussing about distribution of the temperature features ना, global distribution of a temperature. तो आज हम लोग देखेंगे third point ना. It was distribution of land and water. तो distribution of land and water. Okay. Now, what is the property of the land? Land is solid. ना? पहले मैं explain करूँगा, then I am going to give you the dictation. So, what is the property of the land? The land is a solid. Land is a solid and water is liquid. Water is liquid. Okay. So what happened when it is solid and that is liquid? They have different specific heat. So it has a specific heat, and they also have a specific heat this side. So which one is having a more specific heat? Land or water? So what is a specific heat? Specific heat is an amount of heat required to raise a temperature by 1 degree centigrade. So specific heat of water is more. तो इससे क्या होता है? They need more energy to raise their temperature, and they need to release more energy to reduce their temperature. So if the specific heat is less, what it defines? It defines the rate of cooling and heating of regions. What is rate here? Rate means change with respect to time. इसका मतलब in simple word it is speed. So what is the role of a specific heat? Specific heat defines the rate of cooling and rate of heating, right? Speed ना कितने fast होंगे तो suppose the two body, one is a land, other is a water, they are on a same latitude, and yesterday we have discussed what is the value of a latitude. That defines rate of absorption. Okay? Angle of inclination, rate of absorption. So if they are same latitude, if the latitude is same, then how the things would be different? Which one is going to be more hot in a day? Land would be hot. This will be warm. है ना? नहीं, in a day. If the day is there, the land will be hot, water will be warm, right? Then in the night there will be radiation reaching into the space because cooling is fast. So what would be the nature of the land? It is cold and the water is cool. Cold मतलब superlative है ना? Water is cool. So how the things are different? देखो specific heat क्या कर रहा है? What is it doing? Where do we have extreme temperature? On land. So land has extreme temperature, and water has moderate temperature. Right? So this is a role played by specific heat. So if the temperature is extreme, उस चीज को हम बोलते हैं continentality. Like we have a Delhi. Delhi is what? Is a land continentality. Summer is very hot, winter is very cold. Whereas a Mumbai is having a moderate. So here we have the moderate temperature यहाँ पे, Mumbai. So this type of temperature is known as moderate temperature. We call it insularity. Okay. So what is the role of land and water? So it creates extreme and moderate temperature. Okay. And accordingly we have the vegetation will going to distribute. Okay. To write distribute. Is this point clear? Okay. To write distribution of land and water. So write its specific specific heat in water is greatest. Hence its rate of heating and cooling is slow. Hence its rate of heating and cooling is slow. Cooling is slow. Whereas specific heat of land is low, thus its heating and cooling rate is fast. Thus its heating and cooling rate is fast. Heating and cooling rate is fast. Check it, right? Next paragraph. Because of the different rate of heating and cooling, diurnal range of temperature, diurnal, you know what is diurnal? What is that? हाँ नहीं, ये diurnal, ये वाला, this is diurnal. Diurnal मतलब होता है day night temperature. What is the coolest temperature in a day, in a night? What time we have the coolest temperature? Just before sunlight. ठीक है? And what is the highest temperature we have in a day? What time? 2 p.m. ठीक है? So 2 p.m. we have highest and 5 p.m. we have lowest. तो इन दोनों के गैप को बोलते हैं diurnal temperature. ठीक है? So diurnal, just simply write day and night temperature. Day and night temperature. Diurnal range of temperature, day and night. Extreme hot, extreme cool. Day and night temperature. So write the difference, because of the difference rate of heating and cooling, diurnal range of temperature and annual range of temperature. Different rate of heating and cooling, diurnal range and annual range of temperature of the places, of the two places in the same latitude, and altitude will be different. Okay, right? For example, next paragraph. For example, if the location is close to oceanic surfaces, ठीक है? अब यहां पर भी you have to write examples, ना? What surfaces are close to oceanic surfaces? One, coastal. Second, islands. So we need to make this point in the mind, because the content will train your mind also. So like coastal location, islands, have small range of diurnal, D-I-U-R-N-A-L, have a small range of diurnal and annual temperature, right? Next paragraph, right? Whereas places located in continents have relatively high range of diurnal, have relatively high range of diurnal and annual temperature. Diurnal and annual temperature. अच्छा, ओके, ड्रॉ वन डायग्राम ना, कैसे डायग्राम करोगे आप? तो राइट डे, नीचे में ऐसे डे लिखना, एंड नाइट, नाइट, हियर राइट ओसनिक सरफेस, oceanic surface, this side write continental surface, continental surface, okay. तो यहाँ पे क्या होता है, डे में इट इज कूल, है ना, इट इज कूल, और आई विल से कूलर, सॉरी, डे का टाइम है ना, इट इज अ वार्म ना, इन अ डे it is warm, it is warm, okay, this one is hot, है ना, so warmer, it is hot. So suppose in the same latitude में the ocean current will have a 10 degree centigrade, sorry 15 degree, let us suppose in a day it has a 15 degree centigrade, same latitude, latitude is same, exactly on the same time the surface would be having a 30 degree centigrade line. Now when the night is there, the temperature would be cool by 10 degree centigrade only, पर यहां पे क्या होगा, in the night it is cooled by 5 degree centigrade. तो देखो तो कितना रेंज है, व्हाट इज द रेंज वी हैव, 25 डिग्री का, व्हाट इज द रेंज वी हैव हियर, 5. So this 5 degree indicates that it has a low diurnal and annual range of temperature, Here they have high diurnal and annual range of temperature Now because of this we call it a continentality, na? This property is known as continentality. And that property is known as insularity, ना, insularity, इसको ड्रॉ कर लो आप. So there we have insularity, continentality. Have you ever been in a coastal area? So where? In Chennai. And what month? Acha, you were born there, that's it. Okay. I'm just sharing in a one incident how I also realized it was a bookish knowledge for me. But one day we were living in a Lucknow, so we friend did what? We made a plan. Let us visit to Goa in January around. It was a severe winter that day. And we made a plan, we had those sweaters, jackets, right? Even we kept in some blanket sort of things. We had a little idea, like it wasn't only the things in a information basis, no realization. And the moment we reached to the Goa, there was no any intent of the winter there in the Goa. We thought, acha, ki ho sakta hai next day the winter will come. Like today we have a sunny days and all, so next day will come. We waited for 3, 4, 5 days. The things was like that it was in the beginning. It was a mild, warm. Right? It wasn't any. So this is how the things are unique. In the people in Mumbai, in Goa, they do not have even like a chance to wear sweaters in winters, right? But this time there was an unusual thing happened. 2 years back or this last year, like winter was severe in Mumbai also. The first time the Mumbaikars, they have given up their Instagram post saying that we have used like a sweaters there in the Mumbai. The thing shows that there is a climatic variation is coming. Last year it had happened. The first time the Mumbaikars, they were compelled to wear sweaters. So they were putting in these unusual pictures. But like they do not like wear. Even in the south, if you go to the south, it is more influenced by ocean. So winter is also very much mild. Summer is moderate, it is not so much intense. But the winter is mild. There in the winter also they do not wear sweaters. ठीक है, तो ये डायग्राम बना लिया आपने? Have you written this? इसको ड्रॉ कर लो आप, ये वाला continental, because this will keep on coming in our content more often. ओके, ठीक है. सो राइट नीचे लिख लो आप. लो डायurnal DIURNL, low diurnal and annual range of temperature, in islands and coastal region, is known as insularity. Right, whereas high range of temperature in the interior of continents is known as continentality. Now we are going to take next point, elliptical orbit of the earth. How it is going to play in a role? Okay. So what is the role of elliptical orbit? So we have learned that day that when the earth revolves, it holds in a 4 position. This is the elliptical path. Yeah. So earth does what? It holds in a 4 position. This is the 4 position, and these positions are on the basis of, and where do we have the sun? Sun is not in the center. It is somewhere here. That is where we have the sun. So due to this, what happened? Due to that, sometime sun is very close. So what date it was close? So it is close during 3rd of Jan. 3rd of Jan it is close. And in the first class we have seen the concept. 3rd of Jan it is close. And this 3rd of Jan is known as perihelion. We call it a perihelion. Okay. Now 4th of July we have maximum distance, that is known as aphelion. Aphelion. Okay, perihelion and aphelion. So during this time, on the 4th of the July, during that time, sun rays are perpendicular on Cancer. So the sun is on summer solstice in northern hemisphere, and it is for winter solstice for southern hemisphere, right? So यहाँ पे लिख देता हूँ. So northern hemisphere में it is summer solstice, and southern hemisphere it is winter solstice. Okay. Now here, this side we have a northern hemisphere is having a winter solstice, southern hemisphere is having a summer solstice. Okay, solstice. Now देखो बड़ा इंटरेस्टिंग चीज है ना, you won't going to realize but you will find that when we compare summer by summer, where do we have an intense summer, in Australia or India? So let us see na, where do we have Australia? So in a okay, यहाँ पे देखते हैं. So Australia is in a southern hemisphere. Capricorn passes है ना. India is on northern hemisphere. So India is on the northern hemisphere. Australia is this side. Now when we have summer in India, so it is June when we have a summer. So we have aphelion. And when we have a summer in Australia, they have a perihelion. अब इसको ऐसे कर लेते हैं, like see, we have India and we have Australia. When we have summer in India, sun is far away. When we have summer in Australia, sun is close to the, it has an aphelion position. It has a perihelion position. And it has an aphelion position. So summer versus summer. So where do we have more strong summer? Australia. ठीक है ना? Australia is having an intense summer. See, is this diagram clear? Because we need to compare June in India with December, January in Australia. We cannot compare winter in Australia, summer in India. Comparison can be done among two equals.
There is more water in the southern hemisphere.
There is a there's a more water in southern hemisphere, so it is basically because this is the one side of the picture. When we have a winters, so what going to be the scene then? When we have winters, sun is inclined. So when we have winters, sun is far away for Australia. Sun is very close to India. Sun is close. See, when we have winter here, sun is in what position? Perihelion. Perihelion. And here the sun is in what position? Aphelion. So what is the nature of the winter in Australia compared to the winters in India? Very cold. So winter and summer both are extreme in southern hemisphere. Okay? So it is winter also and summer also. Both are around 7% more. 7% more in the southern hemisphere. Okay? So where do we have more annual range of temperature, in northern hemisphere or southern hemisphere? Southern hemisphere. The range of temperature is more in the southern hemisphere. So summer is very cold, summer is very warm, and winter is very cold. They have very, so the intensity is more than 7 to 11% more in the southern hemisphere. But why do we have more cold surface? It is because of the Antarctica. We're going to take these into account. Na? Antarctica is a land, Arctic is the ocean. Land में cool होता है तो it has a large ice comes. So let us write इसको लिखो आप. So what is the role of these currents, this elliptical path? They distribute temperature between two hemispheres. So right, लिखो right. So solar insolation received by Earth, solar insolation received by Earth while it is at perihelion, perihelion is 7% more, compared to Earth's at aphelion, Earth at aphelion. ठीक है, अब ये डायग्राम बना लो आप. इज दिस डायग्राम क्लियर? ठीक है, तो ये डायग्राम बना लो. Done? So in Australia, summer is intense, winter is severe. Why the people in Australia are fair in color than Indians? They are having a fair complexion despite having so much hot condition.
They are from European.
They are actually they are prisoners. They are prisoners. Like that island was treated as a jail. Like Andaman Nicobar was a jail. For the Britishers also, they used to send those who were not having those culture, na? ठीक है. So right, next point इसमें ऐसे लिखो, right? While Earth is at perihelion, northern hemisphere has winter season. And southern hemisphere has summer season. ठीक है, ब्रैकेट में 3rd of January. Right, with the additional energy, winter is going to be mild. With additional energy, winter is going to be mild. And summer season is going to be hotter. In perihelion. ठीक है, right. Next paragraph, na, right? With subtraction of energy during aphelion, summer season becomes mild. And winter season become colder. winter season become colder. ठीक है. अच्छा, इस डायग्राम में add, if you want you can add here. What is the nature of summer season in northern hemisphere? Mild or extreme? In northern hemisphere. Huh? नहीं, okay, but comparing with the northern southern hemisphere, it's mild. क्यों? देखो आप, northern hemisphere में summer is mild. Why summer is mild? अभी just हमने देखा था ना ये कि when we have a summer, distance is far away, so that is why mild. Is this graph clear? ये वाला, the Indian summer in India, summer in Australia, so distance is less, perihelion में ना. So in the northern hemisphere, summer season is mild, है ना, whereas in southern hemisphere, summer season is hotter. Whereas in northern hemisphere, winter season is mild again. We have a mild, and in southern hemisphere it is colder. Cold, not colder, like cold. So the northern hemisphere is having a mild summer, mild winter, and it is having an extreme winter, extreme summer. It is because of aphelion, perihelion. इसमें डाउट है तो पूछना है ना, तभी तो you will be having an advantage. If you are coming in the class, you will be having two advantages. Most of them are sitting there in the online, but my suggestion is first 20 minutes every day will count too much for your progress. Why? Because we're going to see, I'm going to train your skills of writing answers. So that is important, and then your doubt can be settled here in the class. So is this things making sense, clear? Now right, next is write wind and their role. Wind. Okay, so what is the role of a wind? If suppose some place is there and we have, this is a place suppose, and Delhi is this side. If the wind is blowing from the Himalaya, we have a Himalaya here. There we have Himalaya. If the winds are coming from the Himalaya, which is a latitude above Delhi and the colder place, so it will going to reduce temperature. It will create in a cold condition. And if the wind is coming from Thar desert, suppose we have a Thar where we have aridity is more, so it will going to create what? If the Delhi is this side, suppose, so it will going to raise temperature. So the source of the wind defines the condition and the temperature of the region. If it is coming from the hotter region, it is going to raise temperature. If it is coming from the colder region, it is going to make temperature less. So ये लिख लो, right? Wind, right? Flow of winds control. Flow of winds control temperature of space. Temperature of the space. Temperature of space, full stop. If a space is under influence of, if the space is under influence of cold wind, its temperature is relatively low. Relatively low. ठीक है, ड्रॉ दिस डायग्राम, ये वाला बना लो, हिमालय वाला, इसमें राइट कोल्ड विंड. cold waves. Okay, relatively low means latitude में देख रहे हैं, same latitude. Temperature is high and there the temperature is low. This side temperature is high, पर इस Delhi के लिए temperature is low because it is under influence of low latitude. ठीक है, इसीलिए relative low. Okay, now write. Whereas if the space is under influence of hot wind, if the space is under influence of hot wind, temperature is relatively high. Temperature is relatively high. ठीक है, so winters में we have a temperature is normal, but here the Delhi's temperature is high if it has influence by some winds. Latitude से ना उसका relatively high होगा. तो draw this diagram. इसको यहाँ पे लू लिख लेना, लू cold waves and this waves. Okay, now write ocean currents. Diagrams are important because it will going to relatively क्यों बोल रहा हूँ? Why I am telling relatively? We are comparing with the same latitude other side. ठीक है? That is why latitude diagrams में this is very important ना? In exam, like reference of everything is important. Same latitude ऐसे लिख लेना, same latitude. Same latitude. One place will have a higher temperature than the other place. Okay. Now write ocean currents. Ocean currents. In GS you might have studied about the ocean currents. Now you will be having a rough idea about the ocean currents. पढ़ा है? अच्छा अभी GS नहीं start हुआ है? अच्छा अच्छा. Ocean currents क्या होते हैं? These are simply a rivers of the ocean. Rivers. The way we have a rivers here in land, we have a rivers in the ocean. But how these rivers flow? So let us suppose we have this side, we have a 0 degree suppose, and here we have the northern hemisphere. This side southern hemisphere. There we have land, water, ocean, and land again. Okay. And this side we have 0 degree equator. Equator. Now what happened? This is how the ocean currents move. So ocean currents move in and clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. Ocean currents. So ocean currents क्या है? These are the rivers. ऐसे याद रखना. So there we have a land. अच्छा, is this diagram clear? ठीक है. Now this side we have a latitude डालता हूँ. I'm going to put a latitude here. Same. This line is same latitude. So what is latitude defines? Same temperature. Okay? So we have some latitude, and there we have the latitude. Dotted line is the latitude. So what it does, it brings warm water. Which one? This one. We are going to bring warm water of the equatorial region more towards a higher latitude. The same one, we are going to bring warm water to move towards higher latitude, and that will going to bring cold water from the polar region to the lower latitude this side. So cold water, it will also bring in a cold water to this latitude. अब देखो क्या होता है कि this is a coast, ना? I am writing in a coast here. Coastal region. There again we have the coastal region. Coastal region. Now, if I am going to put in a scale, so we have the east, north, south, west, है ना? If I am going to put in a direction here, so south, west, east, north. तो अब क्या है कि here on the same latitude, western coast is having a temperature less, low temperature, whereas in the same latitude, eastern coast is having a temperature high. Despite having the same latitude, because of the current, coastal temperature is different. Here, the temperature of the east coast is going to be high. There we have a low temperature. ठीक है? Is this diagram clear? So, despite having a latitude which indicates the same amount of absorption of sun rays, we have a different temperature because it brings a temperature feature of the lower latitude close to this coast. And the polar water, when it melts, it creates in a cold water current, so it will going to drop the temperature of this latitude. ठीक है? तो इसको ड्रॉ कर लो. So ocean currents plays an important role in defining the temperature of continent or coastal region. Coastal region. So ऐसे हम लोग को बात करना है. So temperature topic is very important because with this pressure belt will develop, humidity concept will come. Okay. So write ocean currents play important role. Ocean currents play important role in weather condition of coastal region. In weather condition of coastal regions. Right. If there are two coastal locations, at the same latitude, two coastal location at the same latitude, and if one is under influence of warm oceanic current and if one is under influence of warm oceanic current and another is under influence of cold current, comma, the location under influence of warm current, is warmer compared to the location under influence of cold current. Compared to the location under the influence of cold current. So write next paragraph. Since ocean current runs clockwise in northern hemisphere, and anti-clockwise in southern hemisphere, and anti-clockwise in southern hemisphere, comma, east coast of the continent, are under influence of warm current, and are warmer compared to west coast of continent, which are under influence of cold current, which are under influence of cold current. which are under influence of cold current. इसमें ईस्ट एंड वेस्ट कोस्ट लिख लो आप, so that you're going to have an idea clear. East coast and west coast. Just to give you the sense कि ये आपको पता है ना ईस्ट कोस्ट वेस्ट कोस्ट क्या होता है, यू नो दिस ना. तो एक डायग्राम में ऐसे मेक इन वन पॉइंट ऐसे लिखो आप. नहीं मुझे ये तो पता ही होगा ईस्ट कोस्ट वेस्ट कोस्ट क्या है, बट आई एम गिविंग इन वन सेंस कि आपको कॉन्सेप्ट क्लियर हो. So that is, let us suppose we have, this is ocean, that is continent, that is ocean again, ocean. ठीक है. Now when we will see continent, we have east, north, south, west. तो ये क्या होगा, that is eastern coast, this side east coast. But when we will see from the ocean side, जब ओशन की तरफ से देखेंगे, we have an east, west, north, south. यहाँ पे west, north, east, south. But when we see from the, अच्छा यहाँ पे it is a west coast. Let us suppose first write here west coast. Okay. But when we will see from the ocean side, जहां पे east coast है ना, we have western margin of ocean, है ना. Where we have a west coast, we have eastern margins of ocean. ईस्टर्न मार्जिन ऑफ ओशन. तो ये ड्रॉ कर लो आप. इट विल कम लाइक मोर ऑफन, इट क्रिएट्स एन डिस्टर्बेंस, कंफ्यूजन क्रिएट कर रहा होता है ऐसे, राइट. ईस्ट कोस्ट इज सपोर्टेड, इट अटैच विद द वेस्टर्न मार्जिन, है ना, ऑफ ओशन. वेस्ट कोस्ट इज अटैच विद द ईस्टर्न मार्जिन ऑफ ओशन. इसको ऐसे भी लिख लेते हैं, ईस्टर्न मार्जिन ऑफ ओशन, Simple diagrams are important because this will give you the clue na, to develop your logic in the next round. Acha, I'll be taking your doubt. So one of the candidate have asked, कि Australia is surrounded by ocean, so it needed to have a less diurnal range, so that the peninsular India also, and peninsular India is also surrounded by three sides from the water. So I just want to, with the reference, I want to give in a sense, yes, the continent of the same latitude in a different hemisphere will have a different temperature, ना? जैसे अभी हमने डिस्कस किया था ना कि समर इन ऑस्ट्रेलिया एंड समर इन इंडिया. सो लैटिट्यूड, इफ द लैटिट्यूड इज सेम, वी हैव अ मॉडरेट टेम्परेचर, यहाँ पे एक्सट्रीम टेम्परेचर. ठीक है, ओके. यस, वाटर प्लेज एन इंपॉर्टेंट रोल इसमें यहाँ पे. अच्छा, इज दिस डायग्राम क्लियर? राइट, नेक्स्ट पॉइंट. Right, orientation of slopes. Orientation of slopes. So what is orientation? हाँ, so orientation का मतलब दो चीज होता है. So orientation, let us see orientation यहाँ पे. Orientation holds two things. एक तो उसका location, and second is direction. ठीक है, plus direction. So these two together is known as orientation. You would be having an orientation classes. What is the orientation classes? There the mentor used to come and they tell what is the direction you have to go. That is the orientation. The direction is important. So if we have a 0 degree, suppose this side we have a 0 degree, okay, and there we have a mountain. This side we have the mountain. There we have the mountain. So if the mountain is parallel to latitude, right? So orientation is parallel to latitude. In that case, there would be, that is going to be northern slope. This is going to be in a northern slope, no? North slope for the mountain. Northern slope for mountain. And this is a southern slope. Is this case clear? It is just like in a Himalaya we have. Himalaya is somehow this way, but that way also we can relate Himalaya. And here in this case, this is southern slope. And that is northern slope. We have learned that overhead sun fluctuates between Cancer and Capricorn only. The first class में, right? So the overhead sun like a moves between these two lines only. That two lines. So that is the extreme point it comes. So if the overhead sun coming to this two line only, so in that case, this portion is going to be like a sunshine. So we have a sunshine is there only. Sunshine. So where we have a sunshine in northern hemisphere ke southern slope, right? And the sunshine would be here in the northern slope of southern hemisphere. So we have a sunshine. Okay, and so that the temperature is high here, and this side temperature is low. There temperature is low. Okay, so iska matlab ye hai, this side we have a vegetation, and there we have a barren land, deserts. So you can see here Tibet is a desert, but here we have a forest, And this side we have the forest. This is the reason why we have this division. So we have vegetation here, vegetation there, and we have a barren land here. Barren land. Okay. So orientation defines like a slope wise division of temperature. So isko draw kar lo aap. I'll be giving a less of dictation now. Huh? But yes, it will going to play an important role. Okay. So right. Orientation of slopes control. Orientation of slopes controls distribution of temperature on mountains which are extending from west to east, Okay, right, next paragraph. In the northern hemisphere, southern slopes are under influence of sunshine, and these are hotter. Whereas northern slopes are under influence of shadow. Northern slopes are under influence of shadow and are colder. Right, next paragraph. In southern hemisphere, northern slopes are under influence of sunshine. And are hotter compared to southern hemisphere. Compared to southern slopes, which is under influence of shadow, with a low temperature. Under influence of shadow with a low temperature. Okay. Now we have last one isme. We have nature of land. So, how the land defines? Land may, if we have a vegetation, if we have barren land, so the temperature would going to be different. Isko likho, I'll explain, right? Surface covered with water, cropland, forest, surface covered with water, cropland and forest have relatively low temperature. Relatively low temperature. Low temperature. Why? Why they have a low temperature? Is it due to? So they absorb more sunlight. है ना? So we have done in albedo वाले class में कि vegetation and water bodies appear dark. If you see the picture of Earth appears dark, navy blue color because of the ocean absorbs most of the light. So despite this, why they are having a low temperature if they are absorbing more? So if we have a suppose same, we have a land and this side, the basic reason is because when the water vapor comes, है ना, and when they like evaporates, right? When evaporation is there, so the temperature which is there in the air is consumed. It consumes. Latent heat of condensation releases energy, whereas the latent heat of evaporation that consumes energy. You might have noticed now when we have a sweating body and when we sit under fan, when these water drops vaporizes, cooling effect comes. So that is the reason. If we have the forest, if we have trees, you might have noticed, even though you do not go close to the forest, enter into the forest, if you go close to the forest, then also the cooling effect comes. It is because of the evaporation. ठीक है, इसको भी लिख लो आप. Right. So surface covered within a water and cropland and forest have relatively low temperature. As energy is lost from surface through evaporation and evapotranspiration. Evaporation and evapotranspiration. ठीक है, evapotranspiration by plant ना, right? Land surface covered with rock, sand has a high surface heating and high temperature. High surface heating and high temperature. High surface heating and high temperature. Full stop. Diurnal and annual range of temperature is also low for surface covered with water bodies. Also low for surface covered with water bodies and vegetation. Water bodies and vegetation. Then the surface covered with barren land. When the surface with barren land. Okay, so this is the end of this topic. We'll take up one more topic on a temperature. We're going to take a temperature inversion concept. You have to get it ready for tomorrow's, na? You have to write point इसमें. So now write temperature inversion, new topic. So okay. Temperature inversion. temperature inversion. First I am going to give you the clarity and then we are going to see why we have a temperature inversion. So normally you have studied that it's not functioning as ठीक है कोई बात नहीं. So temperature inversion, we are looking at the temperature inversion here. Okay, so temperature inversion. Now what is the normal scenario that the lower temperature and the upper layer. So we have an atmosphere, this side we have the atmosphere. Okay. Now atmosphere is having two layers, lower layer, upper layer. So lower layer is a warmer layer and upper layer is a cooler layer. Why so? Yesterday we have seen a concept, because there are two reasons. When the terrestrial radiation is going up, we have a more absorption this side. Second, due to conduction also, conduction, the temperature is transferred to the air in contact. Second, absorption is more here, absorption is less. Okay, so that is why the temperature is warm in a lower layer, cool in a upper layer. But sometimes, so this is a normal condition. In normal condition, lapse rate operates in this way. Temperature decreases, normal lapse rate. Now but what happened during temperature inversion condition? That the lower air become a cooler air and upper air become a warmer air. अब ऐसा क्यों होता है? Why it happened? When the air is dry, so that there is a less absorption. Second, if the sky is clear, the cloud does what? Cloud let these radiation reflect. So if there is no cloud, terrestrial radiation is reaching to the space. So this leads to cooling, rapid cooling. So we have a rapid cooling. And then when there is a rapid cooling, due to conduction also, the air in contact acquire the cold condition of the surface. When the air is there and it's going to come and touch the cold surface, if you have the ice is there, so you will find air also become cool, because the property transferred due to contact. So due to this, rapid cooling makes surface super cool. Rapid cooling is permitted by clear sky, calm condition, when there is no wind, so that they won't going to disturb. Then dry air, clear sky, dry air. So we have a cooling is very fast. Acha, this happened when this is a net terrestrial radiation to space. So it happened when during long winter nights, because in night only radiation reaching to the space. So that is where the temperature cut trend becomes opposite. The lower air become a cooler air, warmer air become a upper air become a warmer air. So that is known as temperature inversion. Under temperature inversion, so temperature increase it increases within a height. ठीक है? अब देखो इसमें क्या होता है? What happened here? What is the nature of this air? This side, this air has a tendency to rise. Why? Because the warm air is a bottom air. Warm air has a tendency to expand. Now because the cold air is this side, this air has a tendency to sink. to sink, and that is where it is a risky. If we add any pollutant, suppose you will inject any pollutant, so the pollutant will move within air up to upper layer. But यहाँ पे pollutant won't going to move. It is going to be hold and hang on the our breathing height. So that is why temperature inversion air is unhealthy air, and the normal air is healthy air. Okay. So this is the one concept only of temperature inversion. We are going to bring in a more of the concept. To write temperature inversion. Right. In the normal atmospheric condition, temperature declines with altitude. Temperature declines with an altitude. At the rate of 6.5 degrees centigrade, at the rate of 6.5 degrees centigrade per kilometer, which is known as normal lapse rate. Normal lapse rate. ठीक है. अच्छा देखो UPSC, if they are going to ask question in GS, they are going to have a different question. In optional, they are going to have a different demand. So tomorrow I'll be giving this question also for discussion. Okay. The once there was a question came, what do you mean by temperature inversion in GS? What do you mean by? They are not interested to know what is temperature inversion. They are interested to see what is your point of view on temperature inversion. ठीक है ना? So it is a process of making atmospheric air unhealthy air. ठीक है? ऐसे सोचना होता है उसमें. Okay. So write next paragraph, right? However, in certain specific surface and atmospheric conditions, thermal conditions of atmosphere are changed. Thermal condition of atmosphere are changed. ठीक है, comma, temperature increases with altitude. Temperature increases with altitude. This is the state of atmospheric condition. This is the state of atmospheric condition in which temperature increases, with altitude. Increases with altitude. It is known as temperature inversion. It is known as temperature inversion. ठीक है, अब ये डायग्राम बना लो. Normal lapse rate, and that is we have this point is temperature inversion. Temperature inversion. Temperature and temperature, na? This one is a normal condition. Normal condition. And there we have a temperature inversion condition. नॉर्मल कंडीशन एंड टेम्परेचर इन्वर्जन कंडीशन. ठीक है, तो देखो इससे यू विल अंडरस्टैंड ना. सो द टेम्परेचर इन्वर्जन इज, this type of temperature inversion is normally which atmospheric phenomena? Lower atmospheric or upper atmospheric? Lower. The air which is in contact with the surface. Okay. Now in upper atmospheric also we have a temperature inversion. It happened where? In ozone. Okay. So there are various type of temperature inversions we have. तो हम लोग इसको लिखेंगे, right? On the basis of surface and atmospheric condition, on the basis of surface and atmospheric conditions responsible for temperature inversion, responsible for temperature inversion, responsible for temperature inversion, comma, temperature inversion is classified into, temperature inversion is classified into first radiation temperature inversion, radiation, second upper air temperature inversion, third valley temperature inversion, fourth frontal temperature inversion, and fifth advection temperature inversion. Advection temperature inversion. Advection. Advection temperature inversion. Okay. तो हम लोग बहुत ज्यादा लिखेंगे नहीं ना, because when things are necessary then I am going to give the conceptual dictation. And I already have a conversation within a management. According to your demand, like if you will study Savindra Singh, my content, you'll find anywhere problem. So we're going to make one notes. ठीक है, demand oriented notes. किसी टॉपिक पे नोट्स मिलेगा, बट बाय आई एम गोइंग टू मेक अ नोट्स ऑन टर्मिनोलॉजीज, डिफरेंट कॉन्सेप्ट्स है ना इन्वॉल्व. जैसे इसमें एक कॉन्सेप्ट आएगा दैट कैपिंग ऑफ इन्वर्जन. व्हाट इज कैपिंग ऑफ इन्वर्जन? सो व्हेनेवर द इन्वर्जन कम्स, whenever temperature inversion comes, है ना, this is where we have a temperature inversion, or let us suppose we have a temperature inversion. So we have a cool air, warm air. It does not let smoke go. Smokes cannot have a chance to go this side. And let smoke hang within the ambient air only. So that is how we have it going to act as a capping of a vertical movement of the air. Right? So such things I am going to discuss. Smokes, I'll let you see some picture also of temperature inversion. ठीक है, तो राइट सबसे पहले लिखो रेडिएशन टेम्परेचर इन्वर्जन. रेडिएशन टेम्परेचर इन्वर्जन. रेडिएशन टेम्परेचर इन्वर्जन. सो दिस इज एक्चुअली रेडिएशन टेम्परेचर इन्वर्जन. ओके, अच्छा, इज दिस कॉन्सेप्ट क्लियर? ये वाला, this temperature inversion will be going to occur when we have a clear sky, calm air, है ना, no windy condition, then we have a dry air, right, and long winter night, so that there will be more of this energy will reach surface, will become rapid cool and like super cool. So right, radiation temperature inversion, it is formed in winters. It is formed in winters in following atmospheric conditions. It is formed in winters in following atmospheric conditions. The first is air is dry. Air is dry. ठीक है, अच्छा, you know what is dry air? हाँ, it does not mean the moisture is not there. Moisture is there, but its relative humidity is less than 50%. ठीक है, तो less moisture, ये याद रखना आपने, less moisture. So air is dry. Second, calm atmospheric condition. Calm atmospheric condition. So calm, na? Calm atmosphere. So in bracket, right? Windless condition. Windless. Windless condition. Why calm atmospheric condition required? So that the energy which is traveling vertically up should not get mixed up, disturbed. Okay? So that we rapid movement of these radiation up. Then third, cloudless atmospheric condition. Cloudless atmospheric condition. Why cloud? What is the role of a cloud? What cloud does?
So it will create a black and stop radiating characteristics.
It creates a
Blanket.
blanket. What is the role of a blanket? It reflects. We have a misconception. We think what? कि cloud absorbs radiation. अगर वो absorb किया, if we are going to absorb, it will vaporize. Cloud will lose its and water will vaporize because heat energy. So cloud does what? It acts as a blanket. It actually reflect. That is why UPSC once asked, what is the role of a cloud? So that is why you can see when we have a cloudy sky. So even though we have a cloudy sky, overcast sky, temperature increases. It should have been less temperature, but when we have an overcast sky, radiation getting reflected back. इसीलिए, that is why we have a temperature. So cloudless. Third, fourth point is long winter nights. Long winter nights. Long winter nights. Why long winter nights? So that it can allow rapid cooling. Rapid cooling is very important. Because देखो, एक चीज समझना है यहाँ पे ना, why temperature inversion? What process is causing temperature inversion? Radiation, conduction, convection, किससे हो रहा है? Which is the main cause of conduction. The main cause of temperature inversion is conduction. So what is the role of a terrestrial radiation? Terrestrial radiation, when it is bringing energy to the space, it is making surface super cool. And air in contact become a cold, but the conduction cannot operate between two layers because air is a poor conductor of heat. So conduction cannot be happened between these two, and that is why this surface become cold, that remain warm. ठीक है, तो conduction, तो इसीलिए rapid cooling is important, है ना? This is rapid cooling. Rapid cooling creates super cool condition. So conduction से the surface become cold, air become cold. ठीक है? So ये याद रखना. तो rapid cooling. So why winter nights, long winter night? It allow more terrestrial radiation to reach to the space. So इसको लिख लो आप. Long winter nights allow rapid cooling of land surface. Allows rapid cooling of land surface. Rapid cooling of land surface. So right now लिखो आप next point, next paragraph. In these above conditions, as there is a long rapid cooling of surface of earth, comma, surface become extremely cold. Surface becomes extremely cold. Full stop. Since air is since air is poor conductor of heat, comma, air in contact of the surface becomes colder. Air in contact of the surface becomes colder, and air above it remains warm. And air above it remains warm. ठीक है? And the diagram drawn ये वाला. So write next point लिख लो आप. Right. In these condition, top of the temperature inversion comma, top of the temperature inversion, comma, a cap of temperature inversion is developed. Cap of temperature inversion is developed, which does not allow to escape of pollutants and industrial smoke. Comma, and these are mixed with fog, to form smoke. इसको बना लो आप altitude. ठीक है, draw this diagram. This is why like air become polluted, na, unhealthy air. This indicates temperature inversion. Okay, unhealthy air. Okay. Okay. Now write, because of temperature inversion cap, comma, during winter season, concentration of suspended particulate is high in the atmosphere. ठीक है, right? Temperature inversion cap is an elevated inversion layer. That limits a convection boundary layer. Okay, so what is convection boundary layer? We'll see in the next slide. So write upper air temperature inversion. Next, ये अभी हम लोग ने देखा था. There are different temperature inversions. So now we're going to discuss upper air temperature inversion. upper air. So write, and I'm going to explain. So write, on the basis of origin, upper air temperature inversion is classified into two types. First is thermal temperature inversion. Second is dynamic temperature inversion. Thermal and dynamic. Now the first is thermal. So in thermal, we have an altitude here, and this side we have tropopause. It goes like this. And due to this, we have temperature inversion cap. This is temperature inversion cap. What it does, temperature inversion cap क्या करेगा? It is going to restrict the movement of Hadley cell, and because of this temperature inversion cap, these cells reduce. Right, so Hadley cell, Ferrel cell, they reduce यहाँ पे. They do not have a chance to go up. So इसको draw कर लो आप. यहाँ पे this is troposphere, and that is stratosphere. ठीक है. So this is a role of thermal temperature inversion. यहाँ पे upper air thermal temperature. So because of the ozone, it does not let Hadley cell and other cells to move up. इसको थोड़ा सा ऐसे बना लो, इसमें थोड़ा सा confusion ना रहे. So okay, draw this one only. So इसमें simply you need to do what? इसको सिंपली यहीं पे ऐसे लिख लेना, आप ऐसे ड्रॉ कर लेना. हेडली सेल, फेरल सेल. ये ब्लू कलर मत बनाना आप. हेडली सेल, it does not let these cells to move up. Okay, so write it is formed above troposphere. Due to presence of ozone in stratosphere, ozone in troposphere. ठीक है ना? Right. Due to presence of ozone molecule, that absorbs UV radiation, comma, temperature increases with altitude. Temperature increases with altitude. Right? The temperature inversion cap, which is at the top of troposphere, restrict atmospheric circulation. Within troposphere in normal conditions. Okay. Now upper air dynamic inversion. Upper air dynamic inversion. अब देखो इसको I will try, but I will explain more when we are going to see adiabatic lapse rate, है ना? तो आगे चल के आप पढ़ोगे that when the air parcel started rising up, the temperature decreases within a expansion. Cooling starts. Rising air में we have a cooling starts. Cooling. Now when the air sinks, so opposite process में warming starts. So sometime what happen, when the air is sinking in some place, it has a warm air and नीचे we have a cool air. ठीक है? So when the air is sinking, so it happens like it has a warm air and cool air is this side. So that is known as upper air dynamic inversion. It happened where? In a rain shadow region. If the mountain say, if the air is going up and sinking, so it creates in a like a this type of valley नहीं है. This is not valley. The air में होता है. It happens in a desert. If you go to the desert, you do not find all time clear skies. Sometime inversion occurs. We have a very faint light cloud, and a very transparent cloud sort of develops. So that is how things happen. And adiabatic. So more understanding will come when you will have the next topic will come. ना? इसको ऐसे अभी रखते हैं हम लोग. We're going to for simplicity and for the structure of the notes, we're going to make it this way. Na? So write upper air dynamic inversion is formed. Upper air dynamic inversion is formed in a condition when an air parcel is sinking. From upper troposphere to lower troposphere. Or from mountain top to valley. So air parcel is heated by the process of adiabatic compression. So we have adiabatic expansion, we have adiabatic compression. तो अभी हम लोग नहीं करेंगे, will not going to see. This is warming is because of adiabatic compression. This is adiabatic expansion. ठीक है, तो यहाँ पे इफ यू वांट यू कैन राइट adiabatic compression which is 10 degree centigrade per kilometer. Okay, this is adiabatic compression. Adiabatic compression. ये डायग्राम कर लो. Well, adiabatic compression. Temperature is keep on rising. Draw these two diagram only. These two part. Okay. चलो I'm in the interval I am watching your chat, no? So you can put your doubts also in a chat, but we'll have in a different provisions. So I have already given a answers every day. I'll review answers. ठीक है. Somebody has made an a point, कि ना, where to send answers. So you can have my number also. You can directly send it to me. My number is 7042 568669. If you want, you can share your number, answers directly to me. I'll be making some short group sort of. ठीक है. Okay. Now, what is the role of these kind of an inversion? It creates a cloudy sky, thin cloud sky in the desert areas. No, this को लिख लो, right? Because of the formation of upper dynamic temperature inversion, because of the formation of upper air dynamic temperature inversion, upper air dynamic temperature inversion, which is associated with sinking of air, comma, there is rainless, cloudless, and a fair weather condition. Rainless, cloudless, and fair weather condition. This cloudless condition is produced. In subtropical region, in the leeward side of mountain. In the leeward side of mountain. Leeward side of mountain. In the leeward side of mountain. अच्छा, just to discuss one more point. देखो क्या होता है when the temperature inversion happen here, condensation takes place. Condensation. What is condensation? Turning of water vapor into water drops. And that is why the fog forms. Fog. And temperature inversion leads to foggy condition. So that is what my point is. When you have upper air temperature inversion, you do not have a cloud, but a foggy condition at a very high altitude will appear. And this, in the foggy condition, we do not have a cloud, we have a very transparent sort of layer of the air, no? Cloudy air develops. That is not qualified as in a cloud, but it is qualified as in a one kind of a like a layer of this type of foggy condition. Okay. Is this diagram related events taking time? Diagram is taking time. Making diagrams. No. So this is what like we have to interact on most of the time. I'll be doing what? I'll try to share PPTs with my own handwritten diagrams. Okay? So in that way, you can have an access, you can have a choice also to draw or not to draw. But I'll be having these diagrams are instantly created diagram. When the thought comes, I draw such diagrams. So that would be like going to be more often in our interaction. Like most of the things are more like my own self-created now. But like I'm going to give you some informed diagram before this class. No? Okay, so we'll take up last topic, valley temperature inversion. Valley temperature inversion. Okay, so we have a valley temperature inversion. What is valley? So keep this thing in mind. Na? Any landform V-shaped is known as valley. If the two mountains coming close, we have a valley. Two mountains comes close, so we have a valley. If we have a river and they are flowing, river valley. If the block will cut and will have a divergence, we call it a rift valley. Rift valley. Okay, so V-shape. Now, what happened in the night? So this is where we have valley. Valley, no? So in the night, what happened? We have rapid cooling from the mountain top. Rapid cooling. Why we have rapid cooling? Because already it has an altitude. We have air is dry here. Moisture is less. So because of the rapid cooling, the top becomes super cool. This mountain top becomes super cool. And when the surface becomes super cool, air in contact will develop, the contraction starts. And due to the contraction, what happens? These like air, they drop and they slide. They come after sliding the surface. So that the cold air, they come in this way. And there we have a warm air already. This side we have the warm air. Lower air is a warm air. So when the warm air is rising up, see here, this side temperature inversion occur. So we have a warm air, cold air here, warm air. And that is why we have a kind of a fog develops, valley fog. That is actually a result of temperature inversion. So this happened every year, every season. This intensity is more common in winters, but the valley fog is all time, all season phenomena. Okay. So right. Valley temperature inversion. Valley temperature inversion is formed in night due to sinking of relatively cold and heavy air from mountain top. to valley floor, mountain top to valley floor. ठीक है, so right, being cold and heavier, being cold and heavier, comma, this air gets settled, this air gets settled on valley floor. This air gets settled on valley floor and force relatively warmer air and force relatively warmer air, warmer and lighter air, which is a valley air, which is a valley air, to rise up, to rise up. ठीक है, cold and heavy, warm and light, right? Warm and light, na? So this is a valley air. That is a valley air, and this is valley, na? That is valley. So that is why the valley slope is cold, na? Because of the sliding of air. Right, next paragraph. Right, this is why the mountain tops and valley floors, mountain tops and valley floors are cold. Mountain tops and valley floors are cold. Hence, frost forms in these two areas. Frost, है ना? What is frost? How it is different from fog? नहीं. Both, we have water drops. If the water drops are hanging on a air, fog. If it is settled on the floor, it is frost. Okay. So frost develops on the floor. In the leaves we have a frost. Okay. So sometime yes, it can even lead to what? Crystals forms. But like even the water is qualified as a frost. It is on the floor, right? So hence the frost forms in these two areas. Full stop. Therefore, the areas are avoided. Areas are avoided since these conditions are not suitable. Since these conditions are not suitable to human health and agriculture. Human health and agriculture. Agriculture. अच्छा, there is one last, एक छोटा सा है, इसको तो हम लोग और भी देख लेंगे. आप frontal लिख लो इसको. Frontal happen when two air masses comes. Warm air mass, छोटा सा ही है ना, because we are going to discuss this in a detail in a air mass topic. Warm air mass with a cold air mass. तो इसमें लिख लो, ये front है. That is front. Front. Don't worry, इसको we'll take up in detail. Front. So front में क्या होता है? Ultimately warm air mass rises over cold air mass. Cold air mass. Rising on cold air mass, right? And that leads to temperature inversion. Temperature inversion. So this is diagram 1, that is diagram 2. Temperature inversion is the next stage of that stage of. Okay, so write one short paragraph, right? It is associated with frontolysis. It is associated with frontolysis, which is a decay and death of front. Which is a decay and death of front. Decay and death of front. Which is formed by convergence of hot and lighter air mass with cold and heavier air mass, with a cold and heavier air mass. ठीक है, बस इसमें थोड़ा सा ये ऐड कर लो आप, लाइट एंड हैवी, लाइट एंड हैवी. यहाँ पे इफ यू वांट यू कैन राइट, इसको आगे भी मैं बता दूंगा. Frontogenesis, and this is known as, this one lead to frontolysis. Okay, I'll explain. इसको हम लोग आगे पढ़ेंगे, but for the simply structure of the this content, I am giving you this point here. Okay, so what we'll do tomorrow? One topic is left, advection, and we'll start atmospheric pressure. I'll be making some arrangement here with my PPTs ready, so things would be more fast in the class. I'll be sharing those PPT with you, and there will be a question on temperature distribution. पढ़ के आना एक बार, तो पढ़ने से ज्यादा important है ना. More you will study, what is more important than a study is to think on the topic. Thinking matters a lot. उसी से you can defeat your competitor. नहीं तो everyone can write the answer. And answers को तो अभी तो I am not taking your answers. Those who are worried to share your answers. Answer तो अभी मैं आपको ट्रेंड कर रहा हूं ना कि आप कैसे लिखना स्टार्ट करो your own answers. तो अभी worried मत होना, आप सबको बोल रहा हूं. Answers के लिए तो we'll have one provision.